Hello, my name is America Robledo, and in this video we are going to be talking about number conversions. I'll be walking through on how to convert binary to decimal and decimal to binary. We will also be looking at octal and hex numbers. So first we're going to be looking at how to convert our decimal to binary numbers. And our decimal numbers are what all of us are used to. There are our quote-unquote normal numbers, and those numbers are based on the powers of 10. We have to convert that into binary language, which are based on powers of 2, and that is what computers operate on. So as you can see on my right hand side, I started dividing our decimal number by 2, which gives us 104, remainder 0, and we always want to write down a remainder even if it is 0, because those are going to be very important at the end to get that binary number. So then I did 104 divided by 2, giving us 52, remainder 0. 52 divided by 2, 26, remainder 0. And I went all the way down until I didn't have any more numbers. So skip a few numbers, 3 divided by 2, giving us 1, remainder 1. And then our final one is 1 divided by 2, 0, remainder 1. Like I said, these remainder values are going to be the values we use for our binary numbers. And our topmost number is going to be the least significant digit, which will be our digit all the way farthest right. And then the one at the very bottom is the most significant digit, which is going to be our digit farthest to the left. And as you can see, now we start with our most significant digit, which is the bottom numbers, and we go up. So it'll be 1, 1, 0, 1, 0, 0, 0, 0, and that is our binary number. So now we are going to be going in the opposite direction, so going from binary to decimal. And our binary number that we are trying to convert is 11010000. It's right here on the left hand side. And when converting from binary to decimal, we always want to start off with this table, which shows us our powers of 2s. So in our first row, we have all of our 2 to the whatever power. So we start off at 0 and then go all the way to 9. And our second row is the value that those 2 to the whatever power is. And here, once again, it's showing us that table. And then we are going to copy this binary number onto our third row. And we always want to go from most significant digit to our least, so from our left to right. And we just move that over. And every time our value is 0 in our third row, we can automatically put 0 as our output for that. And when our third row is 1, that's where we are going to be putting the value for the 2 powers. So 2 to the 4th is 16, so we have a 1. That's going to be 16th, and then over here 2 to the 6th is 64, and then 2 to the 7th is 128. And now all of those values at the very bottom, we want to add those up. And we obviously don't have to write down our zeros. So basically, we're just adding our 128 plus 64 plus 16. And when you put that into your calculator or do that mentally, you get 208. And that is your binary to decimal conversion. So that's our binary number to the base of 2, and then our decimal number to the base of 10. Right, our third number conversion is going to be looking at binary to octal. And we always want to start off with our octal table, which is the table we have here on the left-hand side. And it's basically looking at the digits on the farthest right and converting those into our binary numbers. and we are looking at 8 digits, which are 0 to 7, and then we have our binary conversions right here. So we were looking at this binary number 101110001, and we want to break that into groups of 3. And as you can tell, the group farthest to the left does not have that third digit. We can always add a leading 0. And we just want to match those 3 digits over to our octal table. So the 001, we want to look at our octal table and see what value that is. So we see 001, that is the same thing as a 1. The binary number 111, we look over at our table, that's a 7. And then the binary number 010, that is a 2. So that will be our octal number, 271. Last but not least, in our number conversions, we are going to be looking at hex numbers. And hex numbers are used to look at any kind of color. In our hex table here to the right, you can see that we are going to have 16 characters. So we are going to be looking at our digits 0 through 9, and we are also going to be looking at A, B, C, D, E, and F. So that's on our right hand column, and then these are the binary conversions of those digits. And we are going to be looking at this binary number 00111 010 0110. Unlike the octal numbers, the hex numbers are going to be broken up into groups of 4. So as you can tell, we started off on the right, so we broke that up into 0110 and so forth. And just like the octal numbers, we are going to match those to our hex number conversion table. So our 0110, we're going to come over to our table and see which value that equals, and that is going to be our 6. The middle group 1010, that gives us an A, and 0011, that gives us a 3. So that hex number, that binary to hex, that's going to give us 3A6. Now we can do the reverse as well. We can get a hex number, and we can convert that into a binary. Essentially, it's the same thing. We're going to be matching our table. So B, we go over to the B, see that that is 1011. We look at the C, 1100. Look at the 4, 0100. And look at our 7, which is 0111. And that hex number is converted to a binary, and it's that long number right here at the end. And that is our number conversions. Thank you.